Hello again. In the previous video in the Fully Homomorphic Encryption series, I used Google's fhe library to implement a very simple mail spam detection example. What it was essentially doing is checking if a single string is part of the email, and if that was the case, we considered the email spam. However, this was not really practical, and therefore I decided to create this repository to improve on it. One of the first things I want to do is to allow users to configure a list of spam strings instead of just using one string. Furthermore, I want users to just write the strings in a file and not have to write C++ code. If you remember from the previous video, there is a big limitation in the fhe library, and namely inability to use dynamic arrays. Therefore, we can't just load spam strings from a file or get these strings from the command line in C++. Instead, these strings need to be available to the compiler at compile time. They need to be static. That is why I decided to create a very simple Python script that reads spam strings from a file and then generates C++ code that has these strings in it. Then we pass this C++ code to the Google fhe library, and then we compile as per normal and generate our binary. This is a primitive way of achieving dynamic array support. We allow a number of strings to be configured, and this is done in a simple text file. Every spam string is given on a new line. We support new lines inside the spam strings by quoting, and we also support the quote character itself by escaping it. An example spam string text file is provided, and it just contains spam strings on every line. In this example, we have a spam string of evil.url1, and then another one is evil.url2, and also another one is new, then a new line, and then line, and so on. In order to use this repository, you need to just copy the is-mail-spam directory to the examples directory of the fhe library. Then you can edit the spam.txt file with the strings that you consider spam. Then you can run the Python script to generate C++ code. And then you can run a simple unit test to make sure everything is correct. And finally, you can run a test bench that simulates a client-server interaction. So let's do it. Let's go ahead and add a new line to the spam.txt file. And if this string is part of the email, this is going to be considered spam. I'm going to add YouTube test, save the file, and then execute the Python script to generate C++ code. Then I can run the unit test to make sure everything is correct. All the tests are passing. And then I can run the test bench that simulates a client server and pass in an email as an argument that reads mail has YouTube test. And we expect that this email is classified as spam. So let's run it. As you can see, it works as expected and the email is considered spam. Let's now briefly talk about how it works. We basically read the spam.txt file line by line, and we replace the strings in a number of C++ code templates. So let's have a look at the templates. One of the most important ones is the contain spam template, which is just a skeleton for a function that checks if a string is part of the email. And as you can see, there are some placeholders we replace. For example, there is an ID, which we increment for every new string that we encounter. We also compute the size of the spam string, and we also replace the spam string itself. That is how the C++ compiler can see the string at compile time. We generate such a function for every spam string. Then we have a template where we call this function, and then we have a top level template where we replace all the definitions of these functions from the definition template, and then we replace all the calls from the call template. And finally, we have a simple header file template where we just replace the max mail size. And we can have a look at how the generated code looks like. As you can see, there are a number of contain spam functions contains spam 0, contains spam 1, and so on, and each one of them checks for a specific string, and then we call them, and if we find that the email contains one of these strings, we immediately break. So we have calls to contain spam 0, 1, and so on. Something that I tried was to, instead of copying this code for every generated function, was to make it a function template, something like that. So we can do something like template, then pass in as a template parameter the size of the spam string. So let's call it n, and then accept again the mail itself and the offset, and then finally accept the spam string, like so. And so on. However, I tried it and the error I got was something like that. Essentially, I think the compiler doesn't support it. And that's why we're stuck with generating a family of functions which are almost the same, and the only difference is the spam string itself. And finally, I wanted to mention my next step, and it's basically making it a real client server. I'm going to implement a client that generates a JSON RPC request which contains the encrypted email, sends it over HTTP to the server, and the server essentially runs the same piece of code and returns a response to the client saying whether the email is spam or not. I'm going to do that in the next video. And please suggest other improvements to the fhe-is-mail-spam repository, maybe open a pull request or an issue, or leave a comment in the YouTube video. Thanks for watching.